So to finish here, if we ever want to get some relationship xy and introduce a parameter to have more available information, I suppose, there's actually a very easy process we can use, where what we do is we just take our independent variable, which is usually x, and we set x equal to t, and that is our function f of t for x. And then to get g of t, we take the value for y there, y is equal to whatever our function of x was, and then just replace. So to understand this, it sounds weirder than it is. We're going to look at an example. So for this example, we want to find a set of parametric equations for y equals x squared minus 7. Like I said, it's actually very easy. It sounds like it's going to be worse than it is, but all we do is you recognize here that since x is our independent variable, we set x equal to t, and that means that we have y equals t squared minus 7. So if we want to talk about x being equal to f of t, well, that's just t, and y is some other function g of t, that's t squared minus 7. And that's it. That's really all there is to being able to describe this kind of relationship in the other direction. And that's all we're going to get really here for chapter 9. There's more in terms of polar relationships and rotations. I'm leaving some of that stuff as extra credit for you guys if you want to pick that up, as it were. What we're going to do next instead is move on to chapter 10, where we're looking at things that are a bit more, I don't know, I guess combinatorial is the word, as we're picking up stuff with sequences and series and a process called induction. And then at the very end, we've got things that are hinting towards some discrete probabilities, but I don't know how much of that we'll get to. Anyway, we're moving on into our last chapter next week. I'll see you then.